Deploy smarter, not harder. Run Docker containers on the cloud without wrestling with the complexities. This is what we're going to talk about today. Hello, you're on Public Spot. I'm George. There are several toolkits available when it comes to implementing containerized applications, but they can become really overwhelming and heavyweight. There are also lightweight toolkits out there that can do the job and leave you less stressed out. And one of these is Docker Compose. Let me show you how I use Docker Compose to orchestrate containers in a cloud infrastructure. So, let's start coding. But before we do that, thanks to the amazing sponsor of this video, AppCloud. If you're in the lookout for a high-performance cloud solution, AppCloud can get you sorted. With a user-friendly, easy-to-navigate platform, transparent pricing, and responsive customer support to pride for, AppCloud can bring ease and reliability in your cloud journey. AppCloud has various data center locations that gets your geo-presence covered and helps with the compliance requirements and data sovereignty that is mandated by GDPR. If you need database servers, infrastructure for your Kubernetes clusters, private network solutions, or cost-effective and developer-friendly server instances, check out AppCloud. With my promo code, you can get an extended 30-day trial and $50 credit when you sign up. The link is available at the top of the description below. On this episode, we will use one of Docker's existing project repository, which is right here. This is Docker's demo or sample to illustrate multiple containers talking to each other. And because I will be enriching this at a later stage, I have forked a version of this repository on my own GitHub account, which is right here. I already have this repository cloned on my local session. So let's switch to my cursor session and have a look at what's inside this repository. This repository has a Docker Compose file at the root, which is the compose.yaml file. This configuration file contains definition for 4 different services. The first, we have Redis, which is normally used as an in-memory cache. The next 2 services right here are for the web application, and the configuration indicates that the Docker image will be built based on the contents of the web directory as a context right here. So let's have a look at what's inside this web directory, which as you can see is right here. This web application is built using Node.js, and based on the contents of this directory, the main controller of the application is the server.js. So let's go ahead and open that file. This code sets up the main route, which is the / route right here, or the root of the web page being visited. What this means is that when this root route is accessed, the web app will fetch a cache value called numVisits from Redis. Then as the code indicates, the value of the numVisits gets incremented. And then it sends a response back to render the number of visits on the browser. And then lastly, it sends the updated value of the numVisits back into the cache. This would explain why a Redis service has been set up at the top of the Docker Compose file. And then the last block opens port 5000 where the web application will be listening for requests. And because we are containerizing the web application, we also have a Docker configuration file right here. This is a simple Docker configuration file that uses node base image and starts the application using a standard npm script command. Now let's go back to our compose file. The last service in the Docker Compose file is the Nginx, and this too is configured to build a Docker image, which is defined right here. Now let's go and have a look at what's inside the Nginx directory in this repository. The Nginx directory contains an Nginx configuration file right here. And as we see here, the Nginx is being used to proxy requests into the web application. Nginx listens for requests coming in from port 80 and then routes the traffic to a load balance upstream, which points to the two containers that are running the web application. What this means is we're not intending to expose the web application to the public, and all inbound requests will have to go through Nginx. And then if we go and open the Docker configuration file, what we have here is also a simple Docker config file that involves replacing the default configuration file that comes with the Nginx base image. This is to ensure that when the Nginx service loads, it uses the configuration file that we just saw earlier. Now let's go back to our compose file. And that's all the services that we have defined in here. Now that we saw the different services that we are starting, we will need to make adjustments to the Docker compose file before we continue doing something else. When running containers using Docker compose, all the services by default run on the same namespace and network. This simplicity allows all containers to be able to talk to each other by virtue of their service names. For example, we don't need to expose Redis port because the web application which talks to the service will be able to do so by virtue of the declared name of the service and the port it runs on by default. So we can get rid of this. Also, we don't need to expose the ports of both the web application services. The web application services are not going to be accessible directly from the internet, so we do not necessarily have to define port mappings for these services. However, we know from earlier that the web applications will only be accessible via Nginx. So what this means is that we need the listening port that has been defined in the Nginx configuration file to be exposed. Hence, we keep the port mapping right here. And now let's do some local dry run on this Docker compose. So let's open my cursor terminal and run the Docker compose up command to start the services. So all my containers are up. Now let's switch to my browser and access port 80 on my local host, which should hit the Nginx container. And the web application loads. And if I keep refreshing this page, the number of visits will keep on increasing. And notice that the web server picking up the requests changes as well. So not only is Nginx working, but also the load balancing that has been set up in the project. Now for the other fun part of this episode, let's spin up an UpCloud server that will serve as our cloud infrastructure to run all the services orchestrated by the Docker compose file. If you don't have any UpCloud account, head over to this URL and start filling up the form to create your account. This URL will allow you to take advantage of my promotion code that will also allow you to avail of free $50 credits and 30-day trial to set up your cloud infrastructure. Once you have your account set, log into your UpCloud web console, and then you can start creating a separate account that you can use for API integrations that you will eventually need for automation. This way, you can configure a least privilege account that you can use for API connections to your UpCloud account. To create a separate account, head to People, and then click on Create Sub-Account. And then you can start filling up all the primary details that's required to create the account. Once all the primary details are set and the account is created, we can then start granting permissions to this account. So if you scroll all the way down on the page of the newly created account, there's a button in here called Go to Permissions. Click this button, and on this permissions page, I have enabled API connections. And because my current use case involves creation of server instances, I will only allow servers for now. And then I'm going to leave everything else as is. which is disabled. And now that we have a username and password we can use for API connections and automation, let's head back to my cursor session. And then I will create a new directory in the root of my repository called infra. I am going to use OpenTofu to automate the spinning up of my app cloud infrastructure. And so inside this new directory, I will create some Terraform templates for OpenTofu to consume. I have this script that I created in the past that will create some baseline Terraform files. So I will go ahead and run this script. So on my terminal session, let me cancel this. And let me cd to the new directory. And then start running the script that will create my template Terraform files. And if I now expand the infra directory, it contains a set of baseline Terraform files. And now I can start updating these empty files according to my needs. So let's start updating the providers.tf. I will add the necessary provider reference for UpCloud in this file. I need this set to make all the necessary OpenTofu components to work with UpCloud. Now, I'm going to update my main.tf. I need to create an UpCloud server, so I'm going to add this resource block. This resource block needs a host name, which is an arbitrary value that defines the name of the server. This also needs a zone. I also need a plan. And then I'm going to set the metadata property to true. And then the next property that I'm going to set is the template property, and set this to use Ubuntu Server version 22.04. I also need to set the network interface and set the type property to public. And then I'm going to set the login property. Notice that I'm setting the user to non-root, and currently the keys property is empty. So what I will do now is generate SSH key that I could use to connect to the server. So let's open my cursor terminal. I am going to create a keys directory in my home and redirect the key files to this directory. And then run the SSH keygen command. And what I'm going to do next is view the contents of the public file. Then copy these contents right here. Head back to my Terraform file and plug that inside the keys of the login property. The next property that I will set is what will take care of setting up the server to allow Docker containers to run and Docker Compose to orchestrate the services that I need. Inside this property, I will add some settings on how the remote execution will connect to the server instance. This connection property indicates that the remote execution will involve connecting to the upload server instance using SSH, using the non-root username, and the private key that I generated earlier. And lastly, the next property inside the remote execution block that I need to add is the inline property, which is a list of all commands that I need to run once the server becomes available. The first command that I'm going to add is a standard installation of Docker as well as Git. And then I also need a command that involves adding the non-root account into the Docker group, which is required to allow Docker Compose to work. The next command that I need to add in here is the installation of the appropriate Docker Compose binary that is compatible with the Ubuntu distro that I'm creating. I need to ensure that the Docker Compose file that I downloaded is executable So I'm going to add a command to change the permission of the downloaded file. The next set of commands involves setting up the server with all the necessary components that I need to make my sample full stack system to work on the server instance. So the first command that I'm going to add is to add github.com as a known host. And then I'm going to add a command to clone the GitHub repository into the server. And then lastly, I'm going to add a command that will run the Docker Compose binary and orchestrate all the services defined in the repository. And that will be all the code that I need to spin up the server instance. Before we start standing up the infrastructure, there is one more that I need to do. So let's go ahead and open outputs.tf. And I will add an output that will define the Nginx endpoint that will allow me to access the system. And now we are ready to spin up the infrastructure. So let's head to my cursor terminal. And before I start running the OpenTofu commands, I need to make sure that the OpenTofu binary is available for use. So I'm going to load this using ASDF. And if you want to learn more about how I set up ASDF on my machine, head to the video somewhere right here. So I'm going to use OpenTofu version 1.9.0. So this is what I'm going to set up. And to be able to communicate to my UpCloud API, I need to export the necessary environment variables that points to my UpCloud API username and password. And now that everything is set, let's start running all the necessary OpenTofu commands, starting with tofu init. And now I'm going to run tofu plan and generate an output. So that plan was successful. And the output says it's going to create one resource. And now let's go ahead and apply. So that has completed successfully and it finished in 2 minutes and 40 seconds. Let's quickly switch to my browser and then go to my UpCloud server. And my new instance is right there and it's running. Now back to my cursor session. Notice that the run has provided us an output that contains the Nginx endpoint. So let me copy that and then switch back to my browser. And then I'm going to access that URL. And that worked just like what we saw locally. And so if I refresh this page, the num visits continuously increases. And notice that the server used switches between Web 1 and Web 2. And that's how we can simplify the orchestration of Docker containers on a server instance in the cloud using Docker Compose. What you can do now is attach this server instance to a proper proxy like a load balancer or a proper domain-based endpoint that will forward the request to the cloud server. And that's all I have for today. Let me know your thoughts in the comments below and send me some likes if you find this useful. And don't forget to hit the subscribe button if you like the content on this channel. Until next time, keep learning and stay safe. See ya.